So I'm going to show you an easy way to solve this LeetCode problem that says the longest palindromic substring. So given a string S, return the longest palindromic substring in S. So the easy way to solve it, of course there are different ways. The easiest, most efficient way to solve it is to use the two-pointer method. So the two-pointer method, actually, you can also use this two-pointer method in two ways. So let's take the simplest method, for example. So the first method says have a function, a helper function that is called is palindrome. So this helper function here is going to return true if a string is palindrome and return false if it's not a palindrome, okay? Now what we are going to do with the original string is that you are going to start from index 1 here and then check the first two items. So you're going to check BA and check is palindrome. No, it's not palindrome. And you're going to move to the next one, B, A, and check is palindrome. Yes. So you're going to now store the length so far. So let's call the length so far to be 3 and the string so far to be B, okay? So at the next iteration, we're going to move to the next one, which is B, A. Is it a palindrome? No. And then we don't. And then we complete it, and then we move to the next one, which is A. We're going to check A. Is it a palindrome? Yes. But we are going to check if that palindrome is greater than the longest so far. It's not. So we don't worry about this. And then we are continuing all the way to the end. So this iteration going here is going to take order of n squared time because we are going to check for each of the items. We are going to check all the other items. And this is going to be our worst case scenario. We're going to start from here and check everything for each of them. So, and this function here is going to take order of n times. So if we put them together, it's going to be order of n cubed time. So it's going to be, the complexity is going to be n cubed. And if you are in an interview, you recognize that this is not very good to have a performance of n cubed. So how do we do better than this? So the method we can use to do better is to use, is to check for its palindrome for each of them, for each of the letters. So it means that for B, we are going to check if it's palindrome. And for A, we are going to check if it's palindrome based on the item surrounding it. So it means that for B, we are going to check if it's palindrome. For A, we are going to check the item before it. That is, we are going to check A, we're going to check B, A, B. That is in case of A, okay? So in case of B here, we are going to check B, A, B. In case of B here, we are going to check BA, B, A, D. So you have this in the middle. So what are we saying? What we are saying in effect is that for each item, for instance, B here, this very item here, we are going to check the items on both sides of these items. So for two, we have an index left and index right. So for instance, if we have this, if we put indexes on them, we have 0, 1, 2, 3, 4, and B is an index 2, for instance. So assuming I is 2 in this case, and we're going to start a left index of 2, which is going to be I minus 1. This is going to be the left index and it's going to give us 1. And we are going to have a right index, which is going to be I plus 1, and that's going to give us 3, right? So it means that we are going to start from here and go outwards from that very item, checking whether the both items match. So if they match, then we know it's a palindrome. So in that way, we are going to reduce the time to order of n squared time because for each item, we are going to use two iterators or two pointers to move in the same time in two different directions in order of n time. So combining it with the iteration going from beginning to end, so that's going to give us only order of n squared time, and I think that is way better than order of n cubed time. So let's see how this plays out in code. So let's go to the fun part. Let's go write the code now and let's see how it plays out in code. So first, let me kind of increase the font here. So the first thing we want to do here is to check the base cases. So the base cases is when the string is empty. So I'm going to say if s is empty, so if the length of s is 0, we are going to simply return. So the longest string here is going to be an empty string, okay? If we look at the question, let's see what they tell us about empty string. So they didn't give us empty string, so we have s has to always be 1, okay, greater than 1. So we don't have any business checking this. So let's check for only one item. And if it's only one item, then the longest palindrome is going to be that item. We simply return it. Now let's also make life easy by checking when length of s is 2. So when the length of s is 2, what do? We are going to return the item if both of them are equal. So in this case, we are going to return. We are going to return s if the first and the second item are equal. So if s0 is equal to s1, okay, return s is equal to, if s0 is equal to s1, then I'm going to now say else if they are not equal, so just return the first item, okay? Perfect. Now what we are going to do here, we are now going to begin some initializations first, okay? So let's go back to our drawing board here. So permit me to kind of take this and clean up here. So if you look at what we just set up, we've checked for here, we've also checked for when there are 2 items. So now we are checking now for when there are 3 or more items. So that's what our loop is going to be doing. And from what I told you before, we are going to start from here, right? This is the only place we can start from that is going to take into consideration both sides. Okay, so it means that we are going to first, we are going to set the longest so far. So let's call it longest so far to be s0, okay? So this is our longest so far, okay? Until we check and find out that there is something longer than the longest so far. So this is just as an initialization. And we need 2 pointers at this point. So let's see. So we have the first point is going to be I. So for now, let's just loop from I is equal to 1 all the way to the end. So I'm going to say for I in range going from 1 to length of the string. Yeah, I think we can add +1 here because the last index is not inclusive. Yeah, okay, great. Okay, so we are now at index I. At index I, which is here, we are now going to initialize 2 pointers. L, let's call it left is equal to I minus 1. It's equal to I minus 1. And right is equal to I plus 1. Okay. So we now have 2 pointers initialized. So now we are going to begin a loop. Okay. Another loop that actually now uses these 2 pointers and goes in 2 different directions. So I'm going to call that a while loop. Now, if we are at point, let's say here, at point, take my pen. At this point, our loop is going to continue looping while the left pointer is 0 or more. The loop is going to continue looping, or the right pointer, let's say we are here, the right pointer is at the length -1, all right? At the length -1. So in this case, we have 0, the right pointer gets to 3, we are going to also stop the loop. So we are going to now begin the iteration while left is greater than or equal to 0, while left is greater than or equal to 0, and because in this case, while left is greater than or equal to 0 and right is less than or equal to, is actually strictly less than line S, okay? So what we are going to now do at this point is to check the items at left and right, right? So we are going to check the two items. So we are going to say if the item at left is not equal to the item at right, because we want to terminate this check if the item on the left and right is not equal. So if the item in the left is not equal to the item in the right, we are going to simply break and start another while loop. Now, after increasing the left and the right. So I'm going to say if S left is not equal to S right, what do? We break. We break out of this loop. There's no need of checking, because even if you find two items the same, it can be a palindrome because it's been broken somewhere. So else, now in the else part, we have a palindrome, okay? We have a palindrome because the items are the same. So else, we are going to now, we're now going to adjust the left so far here. We are going to adjust our left so far if the items, the palindrome found, in this case, the palindrome will be running from left to what? To right. So if the item going from index of left to right, if this item is greater in length, if the length of this string, this palindrome, because a palindrome was found, then we are going to update. We are going to update our left so far. So I'm going to check that if, okay, why am I having this error here? Yeah, let's just take out this. Okay, so I'm going to say if the length of the string called S of S going from left to right plus 1, because remember the right index is not inclusive. If the length of this string is greater than the length of the L so far, or the length of the existing length so far, we are going to replace the length of the LSF, which is our existing longest the longest string so far. We're going to just replace it with S left and right plus 1. So if we check this against this, let's take for instance, we are left so far in this case. Let me just do a little bit of cleanup. So our left so far, we initialize to our left so far left so far we initialize it to B. You remember when we say LS of 0. Now in this case, BAB, right? BAB, we are going to now because in this case our left is 0, our right is 2. So we are going to now set the left so far to be S of 0 to 3. Okay, so S of 0 to 3 is going to give us BAB. So we are going to update our left so far. Yeah, so I think I'm getting this syntax a bit wrong. Sometimes I mix it up, so it's going to be a colon actually, and this same here as well. Okay, so we are going to replace our left so far, and let's check what else do we do. Nothing. And regardless, we are going to advance our pointers. So I'm going to just advance the left to be left minus equals 1, and because I'm now advancing the left one step minus, I'm going to do the right plus equals 1. Okay, so I'm advancing the right pointer as well. Okay. Okay, so this is basically it. At the end of the day, let me just check if I'm not missing anything. We are simply going to return. What do we return at this point? We are going to return. Just give me a second. We are going to return LSF. Well, that line so far, okay? So this is what we are going to return here, and yeah. So now there is a catch because if you look at it, we are checking that there is an item in the middle. What if there is a situation where there is no item in the middle? For instance, if you look at the string s is equal to b, for instance, okay? And we can, if we set the item, if we set here, it means that we cannot do a check this way, you see. So there must be a way to also test for palindromes where the palindrome is even number of items like this. In this case, we are not going to be doing mid. We're not going to be taking I and I plus 1 and I minus 1. Here we are going to be simply taking I. The left here is going to be I because if we set it to here, okay, the left now is going to be I minus 1 and the right here is going to be I, okay? So in this case, we now have 0 and 1, and at that point, we can simply do exactly the same thing we did. Unfortunately, I don't know exactly how to reduce the code base. So what we are going to do here is to just replicate the code base. So it means that when we do this for loop here, we are going to do it a second time, detecting even number palindromes, because what we have here is odd number palindromes for this very loop right here. Okay, so I'm going to copy this time is going to be for even number palindromes. So I'm going to kind of adjust this and kind of reduce the font to make the code a bit readable. And then I'm going to put a comment here. I'm going to say for even number palindrome. Okay, and this for loop here is going to be for odd number palindrome. Okay, so this is what we have here. Now, how do we adjust the even number palindrome to fit? Again, we have that we are setting our I to 1 to length of s minus 1. That is remains the same, and we are setting our left to I minus 1. Our right is now going to be I, like this. So if we now look at this while loop, if the both of them are not equal, we're going to terminate. But if both of them are equal, we are now going to check. Now we have to take a look at this condition here, just make sure it works. So if the length from 0 to 2, in this case is 0 to 1, because this is, once it comes here, we found another palindrome, we are going to adjust this. And of course, we do an increment here. So I think we should be good to go now, except that I need to just check. Yeah, okay. So let's run this code and let's see what we have. So I'm going to click on the run button. And yeah, and it works. So let's see if we can submit. I hope it works. Let me make some room here. So I'm going to submit this code now and let's see. And it works. So it's a runtime 18.36, 1836 milliseconds, faster than 35.9% of Python 3. That is not so bad. I think we did a good job and I think it's quite intuitive. So I'd like to thank you for viewing. Please remember to subscribe to my channel, and if you have a particular challenge you want me to handle, please leave it for me in the comment box below this video. I remain Kindson the Tech Pro, and I'm always there for you.